Hello there, this is section 1.5 and it's all about scientific notation. Scientific notation is a way we can represent a number that has a lot of digits into it, but in a smaller way. And this form we're going to be using is anything in the form of p times 10 to the k power. Now the k has to be a number that belongs to the set of the integers. So k has to be an integer, whereas p has to be a number that is at least 1 but less than 10. So it can be anything from 1.0 all the way up to 9.99. And with k being an integer, that means it needs to be a negative or a positive number. No rational exponents here. Now, you can see we're going to start with 3 examples. I rewrote these because the formatting got a little goofy on those. So just going to rewrite them as exponents here. Now we have scientific notation. We also have standard notation. This is also sometimes called ordinary notation, so you might see that on your homework as well. Now, when we are given a number in scientific notation and we have to change it to standard notation, the first thing we want to look for is going to be the exponent, if the exponent is negative or positive. So in this first one, since our exponent here is negative, that means we need to move that decimal in the 6.17, we need to move it to the left. Negatives get moved to the left. So move, I'm just going to abbreviate left. So we need to take this decimal here and move it 2 places to the left. Now when we write our answer in standard notation, it would be this 0.0617. Now anytime you have a decimal, you want to make sure you put a number on both sides of it. So we want to fill in with the extra 0 there. Okay, with the next one, we have 2.4 times 10 to the 6th power. Since this is a positive exponent, we want to move to the right, move the decimal to the right. And right, we're going to move it 6 places. I'm going to come over here and write the 2.4 again. And we want to move it 6 places to the right. So 1, 2, 3, 4, 5, 6. And then you need to fill this in with zeros. So make sure you count it correctly. That would be 1, 2, 3, 4, 5 zeros we're going to put after the 4. So 2 and a 4, and then 5 zeros. 1, 2, 3, 4, 5. And that would be our standard notation for that number. So go ahead, pause the video and try the next one. Okay, you saw that it's a negative exponent, so we know we need to move the decimal to the left 4 places. Now here are decimals right there, even though we don't see it, that's where it's at. And we go to the left 4 places, so 1, 2, 3, 4. And you can see we need to fill this in with 3 zeros, so it's 0.1236. And again, fill that in with a 0 on the left of the decimal. Now you will notice for the 2 that have negative exponents, both of the standard notations are a number less than 1. So just keep that in mind. If you have a negative exponent, it needs to be less than 1. Positive exponent, it's going to be a larger value number, something greater than 10. So now we're going to take numbers in standard notation and write them in scientific. Just looking ahead, we see these two, how they're less than 1. That tells us that the exponents will be negative. So let's look at the first one, 2,380. First, we need to create our value of p. So we need to put a decimal someplace in that 2,380 that'll leave it between 1 and 10. All right, that would be 2.38. And then we want to multiply it by 10 to some power. Now we know it's going to be a positive exponent since it's not a small value number. We put the decimal here, so we say, okay, how many places is it from here to where the decimal was? Right, and that's 3 places, so it's 10 to the 3rd power. And you can always check that, say, okay, if I move this 3 places, 1, 2, 3, am I getting this number? Yes. So now this one, we need to start by creating our p-value, which in this case would be 5.32 times 10. And this one's going to be a negative exponent since it's a small value number. And we ask ourselves, okay, how many places is it from here to here? Right, that would be 4 places. So this would be a negative 4. Go ahead and try the last one. Right, we'd have 1.25 times 10 to the negative 2 power. Good. Now, with the next one here, it says example 1, use your calculator to perform the indicated operations, answer in scientific notation. So these 3 problems here, you are just going to be typing these into your calculator. So type in calculator. And you can see that's what I've done right here in the picture. But what we need to do is look at how to write our answers. This whole thing here is not going to be our answer. What we want to do is look at the numbers that we are given in the problem, and we want to look at their significant digits. You can see here that we have 3 digits, 3 significant digits. Here we have 3 significant digits. Here we have 5. Think back to what we did in the last section, or in 1.3, sorry, we always want to use the least amount. So that means we want to have our answer with 3 significant digits. So this one, if it's 1.915, we'd answer as 1.9, right, that would be a 2, and this is times 10 to the negative 8th power. That's how we'd read that calculator screen. If you're having troubles typing this, make sure you follow how I did it. If not, please reach out because there's other ways you can type it that would give you an incorrect answer that might appear like you typed it correctly. Letter B, you see we have 3 sig digs, 3 sig digs, and 3 sig digs. So now we want to round our answer to 3 sig digs, right, which would leave us with a 1.81 times 10 to the negative 5th power. And last but not least, we type that one in. Again, we want to use 3 sig digs, so this would be 1.53 times 10 to the 11th power. Okay, so go ahead and pause the video and read through the last example. Okay, you can see that an airplane travels this many miles in one trip. It tells us that this airplane makes the same trip 3 times a day, and we want to know how many miles is that in 30 days. Well, we want to make sure we show some work here. If we do 2035 in one trip, but it tells us it does that amount 3 times a day, we want to multiply it by 3, and that would tell us how many miles per day. But we want to know for 30 days, so we need to also multiply by 30. Now, when we multiply those 3 things together, we get 183,150 miles altogether. However, we want to write the answer in scientific notation to 3 sig digs. So if we look at 3 sig digs, it would be those 3. Scientific notation for those would be 1.83 times 10, and we'd have to look to see how many decimal places. Well, we'd want to look at the decimal places from 1.83 all the way to the end there, which, right, that would be 5 places. So 10 to the 5th power, and that would be our final answer. All right, that's all we have for section 1.5. Please reach out with any questions. Also, I just want to reiterate, make sure you can type these into your calculator successfully. Enjoy the video. Bye.